Sup, Sarah? Today is February, almost said January. It's February 17th. It is 3:23 p.m. And first of all, I'd like to touch on the fact that you were very apologetic in your last video, and you shouldn't be, especially considering you posted it on Friday, and I am posting this on Wednesday. So really, it's not your fault. You're fine. We're struggling in February for some reason. January went really well. We did a really good job. In February, we got busy. And that's perfectly fine. Don't worry about it. You also talked about exercise and how much it hurts. Might I give you a suggestion? You could take the Jordan Stomps approach and don't exercise. See? So finally, I'd like to touch on a topic, math. So today in Calc 3, we learned a new process that significantly shortens the work you have to do for a lot of different processes when differentiating. And it would have been lovely to know that back in Calc 1, but no, they had to save it and wait until Calc 3 to teach us. And because of that, I wanted to touch on one of the problems in math, and it's the fact that the entire basis of American math, well, world mathematics, how it's taught, is that each teacher has to lie to you. And then as you move forward, that teacher, like the more advanced math teachers, will actually tell you the truth. So you're in first grade, and you're learning addition and subtraction, and you learn the basics of everything, and then the teacher tells you it's cool because you can build numbers up and you can subtract numbers, but you can only subtract a smaller number from a bigger number. You can never do it the other way around. That never happens. And then fourth grade comes around and they tell you, well, actually you can subtract larger numbers from smaller numbers. It just gives you a negative number. It's a number line. And you're like, well, why didn't you tell me that in the first place? It would have been really easy to know that. And then you go on to do complex algebra and stuff like that, and they're like, you can do this, and you can divide by this, or there's infinities, but some infinities are bigger than other infinities, and like you can't divide by infinity. And you go into calculus and they say, well, you actually can divide by infinity if you just use like L'Hopital's rule and stuff like that, and it's ridiculous. Math needs to get it together and tell us the truth. You need to straighten everything out and be like, you know what? Here's the thing. You can do this. We're going to tell you how to do this. Okay? And if the student says, hey, can I what about 3 minus 8? You're like, you know what? You're right. It's called a negative number. And you'll get to that next year. Smart, isn't it? Smart. It's ridiculous. Same thing happened with L'Hopital's rule. L'Hopital's rule happened, and this theorem that we learned today happened. It's just, you get taught these really complex things, and then they teach you the really simple way to do it, and you're like, well, why didn't I just learn that in the first place? However, I will say that it is really cool when you have those aha moments in calculus. When you're taking Calc 1 and you're learning about limits and all this, and you say, all right, here's the complicated process to find out what a function approaches as it moves to this value. And then they teach you what a derivative is, and you're like, oh my gosh, that makes so much sense. You can just, rather than going throughout this long process to find a limit, you can just take a derivative and there's your slope. And then you go to do an integral and they're like, wow, it's like the area under a curve, and it's basically just like multiplying the horizontal axis by the vertical axis. And then you go on to learn L'Hopital's rule, and they're like, well, when you're taking the limit and you have 0 over 0 or infinity over infinity, you can't actually find a limit. And it's a really simple process. You just take the derivative of the numerator and the denominator. And then you go into Calc 3 and you're learning about implicit differentiation, and they give you the it's the implicit function theorem, I think. Yeah, it's the implicit function theorem, and you're like, wow, I don't actually have to take this number, take the derivative, then take that differentiation and implicit and find or solve for the derivative. I can literally just take this derivative over this derivative. The negative of it is the answer. Crazy. Gotta love math sometimes. Anyways, rant over. I'm going to make some tea, do some homework. I will call you tonight. Enjoy dinner, by the way, and I hopefully will see you. Actually, pause before I say that. I think it would be a wonderful day if we did, or a wonderful idea if we did every other day, or maybe like somewhere between like 3 and 4 videos a week. So I'm kind of thinking like, you can do a video Friday if you want to. If you don't want to do it Friday, you can do it later in the weekend. Kind of up to you. I don't know. I kind of wanted to do a video today because I had something interesting to talk about. So I mean, maybe if you just, once you find something interesting to talk about, you can do a video that way. I don't know. It's up to you. You do you. But yeah, video every other day is fine with me. Let's do it. So I love you very much, and I will see you not tomorrow, maybe Friday or the weekend. Probably Friday. Love you.